And again, I'm terribly sorry for the delay. I'm not sure what happened, but I'm happy to welcome all of you finally for the webinar. Thanks for staying around. Jim, and without much further ado, may I hand over to you directly?
Sure. And can you see the title slide, or is it the presenter view that you're seeing?
Yes, we can see the slides. And if anybody has got any questions, I would ask you to type them into the chat window. And I'll then read them out loud at the end of the meeting so that we can start the discussion. There's a questions window.
Thanks.
Where you can enter those questions. Okay.
All right. Well, thank you everyone for sticking it out, and glad that we. Thank you, Andy, for making this work and for setting up this webinar in the first place. I'm excited to give a little bit more information and detail and kind of an update of where we've come in the last, I guess, 5 months since P8. It's been exciting to continue working with this system and making some additional improvements. So I'm looking forward to talking to that a little bit more. This is a kind of extension of the talk that I gave at P8, so I'm going to run through a little bit about who we are just to understand the context we're coming from. The Vermont Monitoring Cooperative has been around for 26 years doing a range of ecosystem, forest health and forest ecosystem monitoring work. So we do that through actually providing ecosystem monitoring, through maintaining a collaborator network that shares information and findings and coordinates monitoring effort for understanding forest ecosystems, and providing a data archive access and integration portal for that collaborator network. And the goal of that is to save data that might otherwise not have a home, and also make that data more available to those who need it to assess forest ecosystem change in Vermont. We take a fairly broad ecosystem view of what a forest is. It includes the soil, the water, the air, and the wildlife, as well as the trees and vegetation. And that leads to a fairly wide-ranging need in our data archive, because it can't just be highly structured data that you might find in the water world or in the air quality world, but it has to be able to work with all of these different ecological sciences. So that's what I'm going to talk mostly about today. We have this challenge that this complex ecosystem processes require a lot of cross-disciplinary work, so we're really focused on any data that's related to forest ecosystem condition, and that provides a pretty motivating statement for needing versioning, because we collect forest health monitoring data on a yearly basis, as you can see in the photo here, that is added to every year and is reported on every year. So this shows our long-term monitoring update from 2 years ago, and that relies on the forest health data. So being able to cite that subset of data while allowing the core data set to continue to evolve is a really critical feature that we're going to need. And I think the forest health monitoring is a great example, because it also shows we might have errors not caught till next field season. For those of you out there that are foresters, you'll notice John in the photo is not actually holding his tape correctly, so he's going to measure DBH wrong this time around, and maybe we'll catch it next year. And we want to go back and update those as we go. So being able to track changes and edits to the data as well is a pretty critical citation issue for us. We do some frequent reporting and publishing, so having these publishable units better described is really attractive. So that's why we pursued this in our adoption effort. The features that we needed from it is that we wanted it to have a light footprint on our database. We didn't want to be storing many snapshots of data sets. We wanted it to work on top of our existing catalog and metadata, which is kind of a custom implementation of the ecological metadata language. So it needed to fit inside that, what we were already building for that. We operate our database out of the University of Vermont, and they have an institutionally managed and maintained PHP MySQL environment that we don't have a lot of liberty to adjust or to say switch over to Postgres. So we had to work within that framework. And mostly we wanted to, because we are a big tent repository and we don't do a lot of heavy managing of the data sets that go in, we wanted the user to drive what constitutes a version. So rather than it being determined by the catalog, we wanted the users to decide when a new version had been created. And that it integrate with our management portal and track granular changes in data without being cumbersome. So this is kind of the state that we got to when we were at P8. We had just started implementing some of the features and really kind of figured this out as we were going, that we had two forms of versioning. And I think this is a little bit of the realization on our part that the dynamic data citation really is meant to address the first, which is dynamic subsetting, storing unique and repeatable queries linked to a correct state of a data set. But we also wanted to use this system for provenance tracking, which I think we did, but it's a different kind of lift, and I think that's kind of been an interesting and useful split to maintain in my mind, that we're trying to accomplish both of these with the same system. A little bit more detail on our technology stack and catalog. It's a traditional LAMP stack. We use jQuery for our front-end UI. We have a project catalog. So when I say projects and data sets, a project is a collection of data sets and other content, such as files and people. And data sets are single data objects with metadata. And a data object can be a database table. An object could be a binary file or an archive of binary files or images, pretty much anything. But with this system right now, we are only subsetting tables, so actual tables within the relational database. And then we have provenance tracking capability for all of these, though we haven't turned it on yet for binary files and images. The workflow that's emerged is that we have kind of three different steps I was going to cover. First is data editing, so actually managing the provenance tracking. So you can modify a data set and append, replace it. So you could append by uploading an additional set of data. You could replace it entirely by removing the existing table and populating it with new data, or you can edit the data in line on the website. The way it works is changes are tracked without affecting the original data table as you're doing that modification process. And then someone commits it to a version by assigning a name and clicking the big button, and they can't make any more changes to that state of the data. At that point, the system computes the result hash and query hash, updates the data table to a new state, assigns a DOI and URL, and then commits a version. The subsetting workflow will allow the person to build a query based off a specific state. So it uses Builder or typing in direct SQL to work against a given version, and then shows the user the subset of records, ensures that there actually are a subset of records, and then if so, then they are allowed to create a new version, a new subset query. And again, they can assign a DOI and URL. I should say, I think that's a mistake. It does not actually update the data table to a new state. This is purely just a storage of a query, and then commits the version. And here you can see that we've spent some time trying to figure out, to make sure that we're tracking the correct provenance and locating the query against the correct table. So there is a branching structure available where you could create many versions and actually go back in time and build queries off of previous versions. So that's all doable through the management portal. The kind of back-end piece that we had to do was building recovery systems in. So because we're not storing in doing the provenance work, we're not storing the actual tables of data themselves. So being able to walk back to get to that version is an important first step for either recovering a prior version or building a dynamic subset off a prior version. So to do that, we first basically create a copy table and out of the existing current data set state, and then compile a set of query steps backwards using our version step table, which I'll show you in a little bit, and then walk that table back to a prior state using those stored SQLs. If they're downloading the version, the dataset version itself, they'll get that point. If they are doing a subset, it walks it back and then subsets that data set into the dynamic query that they had originally requested. As we were building this out and trying to marry these two together, we had to deal with the unversioned issues that come up. So we do allow people to turn off versioning. So if they just find it's too cumbersome or it's not working for their data set, they can actually turn off the versioning, and we had to come up with a system to secure and kind of isolate the existing versions from whatever they might do to the data set after that, because they could delete it, update it, add new columns. We wouldn't be tracking it. So we have spent some time figuring out how to kind of isolate those versions from the current data set so that the user can continue on without too much cumbersome confirmation questions. The other kind of potential thing people could try and do is wanting to turn on versioning. We've set versioning to be on by default from now on since we've got it. So when people upload new data, it's versionable. But if they turn it off and then try and turn it back on, if they've made any changes to it, they're not allowed to because we basically can't know that we can track the data set back to the original state. So we've, for all intents and purposes, someone could turn it off and then back on, but they couldn't turn it off, do something, and turn it back on. We've had to secure that workflow. I put this slide up at the adoption session. It was a couple columns shorter for each of these tables, but it really hasn't changed much. The initial recommendation provided us everything that we needed, the things that so we have a version ID and a dataset ID that links the version and the datasets together. User supplied version name, system supplied version ID. This is more of a, I should say, this is a primary key, and this version ID is more of a dataset specific increment. So they get version 1, version 2, version 3. So different version IDs. Person ID of the person who made the version. If the query hash, the result hash, you can see it's null when it's not a saved version. Timestamping, and then version type. So we needed this for defining versions that were either append types or edit type versions or a subset type version because there's slightly different system behavior based on which one it was doing. The parent version, which was basically a provenance tracking and also identifying for subset queries which the target version was. And then the digital object identifier. So this is one per version for each data set. The step tracking table, which is a child of that version info table, tracks the individual steps in order, so how to walk from one data set to another. And this one, the only thing we added as we were finishing out our implementation was the step type so that we could separate out or perform the right steps, the right actions on each step. And it's stored as the full SQL for going forward and the full SQL for going backwards, so you can go from one state to another using the table, and then the order in which this happened. And we did a little bit of assessment of how much data duplication we were doing by this. So you can imagine if you were to, say we have a 10,000 record meteorological data set and you want to add another year's worth of data and put it in, so you add another 10,000 rows. The quantity of data that we're storing in these individual SQL statements is on the order of tens of kilobytes, so it wasn't as large as we were actually expecting. It's obviously not scalable to petabytes, but for our purposes, where we're dealing with the 10 to several hundred thousand row data sets, this is not so bad, and it works well for us. And all this is to say we haven't implemented the binary version. We have all the pieces in place, but we haven't actually turned it on where if people are uploading like an Access database or a raster zip file or some other non-table type data set, the version info table could persist, probably missing the query hash and result hash, but at least we'll be able to track versions as files, so we can store those files. Those files would then be stored multiple copies on this system, and part of the reason we haven't implemented it yet is because we want to think through a little bit more what we do with large data sets such as rasters that someone might want to make a small tweak to, and the data spiral that we would end up there if we allowed them to do many versions. These are the questions and challenges I put up when we were in Denver. So we have challenges of large updates, recreating past versions and garbage collection. We have questions related to best approaches for query uniqueness and normalization, hashing results and strategies, and whether or not we were dealing with a linear progression of data or a branching network, and if that's desirable. At this point, I feel like we have solved most of these, the large updates, the recreation of the past versions, those are done. I think we need to just, I think we have a way forward for the query uniqueness checking and normalization, and we just need to finish implementing it. And we've done we feel confident that we have a good approach to the data progression, but we still haven't really cracked the nut of effective result hashing strategies. And I think that's going to come up as we address this question here, the query uniqueness checking and normalization. We'll also have to be thinking about our results. So that's the challenges and questions that we've come up with. Still to come, we still haven't done our garbage collection, and I hope it looks a little bit better than this, but in scrolling through the database, we're definitely have some entropy that we need to handle. And those result hashes, right now we're just hashing the table primary key in the first column of data and the record rows, or sorry, the table headers as the hash, and that's those deemed to be a kind of good balance between high load on the server to compute large hashes versus something that's relatively unique. That should be relatively unique for these data sets that we work with. And so far it seems to be working fine. And we are going to see how much uptake we have on the web-based data editing. It might be useful for a very small subset of people to actually edit their data through the website, so we may or may not do data editing validation and instead focus more on just allowing people to upload additional sets of data onto their existing data sets. I think I talked really fast, so I just got to say thank you again to the MacArthur Foundation and the Research Data Alliance for building this out, and to the U.S. Forest Service for providing some of our core operational funding, and Fran and Yolanda and other adopters, especially you all who've shared experiences with us as we've been doing this, and our VMC cooperators to make the database possible. And I wanted to just give a quick tour of what this actually looks like on the website, so forgive me as I do an actual live demonstration for better or worse. Let's see. So this is our management portal, and if someone were to go down to versions, this is the steps that are stored in the data system. So we have, this is some meteorological monitoring data. We have 3 different versions here. So this is the one that was originally uploaded. This was made by adding 2010 year to it. This is made by adding the 2011 year to it, and this is a subset on version 3. So you can click on the view and it'll actually take you to the state of the data as it appeared when it was created. So this is all in the back end for the manager of the data set. You could mint a new DOI or just grab the data if you want. It shows you some related subsets, and clicking on that brings you to a dynamically created subset that's built off that table. And if I were to go back to dataset versions, I could actually define a subset of this data, and it takes a little bit of time to load because it actually loads all this data in. I can select which data I want to version against or subset against, so I can load that up, and I could just write a query string, say if I want my evening rain, I could do so I've got 16 records where there is significant precipitation in that subset of data. And it shows me the current subset down here. I can click Save to a new version. And it's created that subset, tied it to version 2. The other piece I could do is edit the data online and make changes into the data set. This is using the editor. We can also use a slightly different pathway to upload it. If we wanted to upload an additional set of data, we can get the template and match that up. Or I could just say, well, I know that on this day, the air temp was off by a couple degrees, and save that and create a new version. So, and that's down here now. So this is our combined view, and then if I were to view this data set on the website, Those versions are listed out here, and in reverse order, actually, strangely enough. So this shows the most recent version first. Everything that's shown in our preview and our data explorer, if you click download, is all linked to the latest version. It assumes that's the one that you want to make available to people. And you could click on, say, a subset, and it gives you some basic metadata about it. This is the unique landing page for a GOI. We haven't started assigning those yet, so we don't have those listed, but if there was a DOI assigned, it would resolve to this URL up on the top. And the system enforces uniqueness on these text-based URL components. So yeah, version name, ID, the type, when it was created, who made it, DOI. I can download just that version and get my CSV. And hopefully it has those 19 or 29 records. Yep. So that's how the subsetting leads to something you can actually download to the system, and it gives you a link to the parent version, so you can see that as well. So that is essentially where we're at. I think we've done most of the pieces. We definitely want to work a little bit more on our front-end display, but we've been kind of getting all the pieces in place to make it so that our users of the system can start managing versions and creating these citable bits of data, and really kind of encourage them to, when they write a paper or when they publish a report, to create that subset of data using the system, or we can help them define that subset of data, and they can have an exact link to the state of that data for whatever use they were using. So that's where we're at. I guess, so unless there's other things you were expecting me to cover, I can go back and do those, but if not, I would just open it up to any questions.
That's great, Jim. Thanks a lot for the presentation, and specifically for the live demo. That was really cool. I've got a number of questions, but I'll first read those questions that come in on the chat window. So the first question is by Jason. He says, there's a question on API versus versioning. When is it more advantageous to create a dynamic API to the data set instead of the versioning? I'm not sure, Jason, I'll unmute you in case you want to explain more on that question.
Yeah, so thanks for taking my question. So yeah, basically, what is the thought process for adding versions of data sets versus just saying, you know what, we're going to create an API, and anyone that wants to connect to the data, they would connect to more or less like a RESTful endpoint, and the data is constantly refreshed, and so they would just query for additional versions that way versus having separate versions. That was more in line with kind of what I was asking.
Yeah, that's a fantastic question. I would really love to have both. The RESTful endpoint API that points to the current state of the data and letting people work off of that, especially for things like our meteorological monitoring, where most of the utilization of that's going to come from people who want to put together kind of an app that they can use for sailing, or that they could use for planning their field work. They want to have the most recent data. They don't really necessarily care about those track changes. The reason that we've seen this as valuable is for allowing people to, it's the recreatability, the reproducibility aspect of it. So being able to get people back to the exact state of data that someone was reporting on when they said trees and higher elevations are starting to show symptoms of decline. Well, which data were you actually looking at? Because when I go and look at your data 3 years later, there's different sets of information, and I can spend the time to say, okay, well, he was looking at 1992 to 2011, and he was looking only at sugar maples, and that person can read the paper and try and get back to that original set of data. But this dynamic data citation, subsetting, and versioning, they should be able to just quickly download and immediately recreate the statistics that were used in a paper. So that's the motivating reason for this, is that recreation aspect. Does that answer your question?
Yes, gotcha. Thank you for that.
Okay, I've got another question by Alberto, how the data hashes are used in the systems management. And I'll unmute Alberto.
Yeah, basically, I get the sense that the data hashes are used to kind of for integrity purposes, as well as to detect changes in the data. Is that how they're used, and how do you actually, in practice, leverage them in your versioning workflow?
Yeah, that's a great question. We are not using them to identify changes in data, so it's not a diagnostic tool. We're using it solely to verify that the recreation step. So when we do that walk back, that recovery step process, that what we got to actually was what we should have gotten to. That's the biggest utility, so that if there was some sort of integrity problem, or if like one of our coworkers went in and deleted a row in the table without knowing what they were doing, that if they did that, then that result hash would fail, and there wouldn't be the right similarity. So that's the key place. So you store it when you create the new version, and then you check when you later recover back to that version. You check the result hash to see that they were actually the same. And right now that's lightly implemented, so we have it kind of in place, but we actually don't fail it at this point if the person doesn't get the right result hash, because that part still, like I said, we haven't quite opened that up to the public yet.
Okay, thanks.
Okay, I've got another question by Catherine, which says, where is the citation? Is the one auto-generated for the user, beyond simply the version name and so on, listed on the version record page? Unmute you as well.
Because I don't feel the need to comment anymore. You can just see if you can take that question.
I'm sorry, could you just repeat that one more time, the question?
So the question was, where is the citation? Whether there is one auto-generated for the user, a citation beyond the version name that is listed on the version record page.
Okay, yeah. That is generally going to be here. This is another thing we've been we've been developing a lot of pieces in tandem, and that's something that's going to be coming up. So we have a lot of data sets without citations, because the way the system used to be and the hundreds of data sets that were in there before we started this project didn't have rigorous or consistent citation. So basically we haven't turned it on because there's a lot of emptiness. And as people are uploading data now with this system, we're actually using, I think, I can't remember which standard we decided to go for, but there's a kind of standard, it wasn't Force 11, but it came out of the ESIP data management workshops, had basically a citation builder approach, and we're using that to assemble the information into an actual dataset citation that would include the PIs, the dates, and the titles, and the DOI that will be minted. So that's the plan. It's not there yet, but it would be on this overview page, and then on the actual version page as well would have a citation for that version.
And just to jump in with a clarifying question, because I was interested in the latter, not the page for not for the overall parent page, but for a citation for a subset specifically. And even if you don't have an example of that, you talked about elements regarding a hash for the query and or the results. Are any of those components going to be included in the citation for the subset?
I hadn't intended to. I guess, do you see a reason that would be valuable?
Not necessarily, but I've heard of other entities experimenting with various different ways to represent a subset in a citation. So I was just curious to see what your plans were, but I don't have a particular model. I've just seen various examples.
Sure. Well, I could definitely see. It's just something I actually haven't considered. So it's a really good thing for us to think about, because we do have long-term data sets where the people created maybe an older subset or an older version, and subset might not be on the project anymore, but the project continues. So we actually don't have a way to track that right now, so that's a really interesting idea.
Yeah, and I think that the idea of a subset is less, I think there's more well established how to cite different versions than how to cite subsets, so I think that's an interesting question.
Right, because it's not just time-based, it's who actually, you can create a subset 10 years later on old data that is your subset and not someone else's, so that's interesting.
Thank you.
Thank you.
Okay, I've got another question by Alberto. There seems to be parallels between the versioning workflows that you have and what the ones implemented in systems such as GitHub in terms of tracking changes, making releases? Whether you've got any thoughts on that?
By that, do you mean specifically the git diff approach, like doing diff approaches?
Yes, or even branching, diffing, creating versions of the software or data at a particular state. I was just wondering if you'd consider this, or if that had given you inspiration for any parts of your system.
Well, I love Git, so I'm sure it was sitting there in the back of my mind, but I think this really started out as an SQL-based implementation, so we were really looking for a database solution that was fairly light on the application code. And so how it was kind of in that portability, so how do we store the information that even if you don't have the code to run it, you could still use the table data to walk another table back. But I guess it certainly parallels, like you said, it parallels what Git does. So it wasn't an inspiration, and maybe we've kind of tracked along the same route. But because ours doesn't deal with binary files, like we don't plan to allow versions of different binary files, I think it's less applicable. Although I guess Git works on a line by line. Yeah, I hadn't really thought about that. It was not intentional if we did parallel that.
It was just a thought.
Yep.
Thanks.
If I may jump in here quickly, Christoph and Stefan have implemented a data citation implementation based on Git for smaller, CSV files type things, where users would upload the files, and in the background, a Git system would take care of the branching, and you could use shell scripts and Java API to do the subsetting. As far as I remember, that code is available as open source. So if anybody's interested in that, I can share that. They've published a paper on that. We've published a paper on that at iPress last year. So that actually uses exactly such a Git versioning approach.
Oh, I'd love to have that reference if you don't mind.
Yep. Can you drop me an email or drop me your email address to the question box, and then I can send that.
Okay. Thanks.
Any other questions? If not, may I jump in with a question of my own? So you decided to implement the versioning via step tracking. So you do and undo changes in the databases to go back to an earlier version. What was the reason for doing so, as opposed to doing the versioning directly in the SQL table? Adding the edit and delete timestamps of individual records and doing it that way. Is there any specific reason for why you've chosen the other approach?
Yeah, I hadn't thought. Part of this is our institutional limitations. We're actually just now upgrading to MySQL 5.6, and in MySQL 5.5, you can't have more than one timestamp column per table, and so you couldn't separate on update and on create events. Doesn't mean that we couldn't have handled it through code. And I guess the actual content of the change would need to be stored as well, especially for updates. So that was, I think that system will work really well for if you have insert and delete, but not updates, if that makes sense. So that's the one thing I would think would be harder to do in a per record implementation.
What you would do on an update is you would mark it as a delete and as a reinsert with the new value, and then just set the timestamp accordingly.
Yep, that would work.
So what most groups have done is basically a column it's basically just a timestamp column, a date column basically. Mm-hmm. And then whenever somebody issues an update command, a trigger fires, catches that update and replaces it by a delete and a reinsert with the correct value. And then that simplifies the management a lot, because you don't have to unroll the database, to roll back the database to a previous state, but can simply operate on the actual database directly.
Yep, that seems very elegant.
No, I was just wondering whether it was a specific setting, because one thing that you allowed that I haven't seen before is actually creating subsets of older version. So I've not seen that happening before. So that's actually quite an interesting setting that you've created here. So we need to take a closer look at that, see what the implications are. You mentioned you had a challenge in the effective hashing. Could you describe what the challenge here is, or what the problem is that you are facing, or that you would like to address?
Let me pull that up. So this is, I think this is maybe an evaluation question on our part we haven't done yet, but in thinking about and starting to try and think ahead of how we would do the result hashing, I can definitely imagine scenarios where where you could have different sets of the data hashing to the same value because of the choice to only include to not hash the entire data set, but to only hash one row of the data, or sorry, one column of the data, right? So our hashing strategy is planned to be this, where we do the table ID, the one column of data, and the rows, or sorry, the headers. And so, an update in any of these other other cells would not be caught by that hash. And when I think about hashing large sets of data, then the compute time would be large, and I just don't know if that's generally if people just sacrifice the server time to do that, or if it's if it's just deemed good enough to do one column. I don't really know, and we haven't done it yet. But I can see problems if you're not hashing the entire data set, and I see problems if you do choose to hash the entire data set.
Mm-hmm.
So I'm not sure what the balance or trade-off is there.
Yeah, I agree. We've had a look at it, but we haven't come to a final conclusion on that either. So one thing that was once proposed was to compute hashes on the row level, and then to include basically the hashes on the row level in the final hash computation. So if some changes happen, if there is some mistake, you could actually figure out whether any of the row hashes would not match. So that would add another column to the table which contains the row hash, and that would allow potentially solving the problem. We haven't, as far as I know, well, Stefan has implemented it even, I guess, but we haven't done any detailed analysis on it yet. I'm not sure whether that might be a viable solution here as well.
Yeah, that seems like it could work.
But I'd be very interested in discussing those issues, because those are exactly the things that we want to take a closer look now. How to actually practically implement the rather abstract recommendations in specific settings.
Mm-hmm.
And another question that I have is that you would allow turning off the versioning. What would be the reason for doing so?
Yeah, so we work with an equal mix of research scientists and monitoring staff from the U.S. Forest Service or State Agency of Natural Resources. And one sensitivity we had is to not make it too hard to get data in the system. And if people are making, wholesale changes to their data, like, oh, we decided to adjust our protocol and we want to report all the data in a different unit, there's a number of ways that they could end up with wanting to replace an entire data set, and doing the work of versioning that could be a turnoff. So we wanted to provide them the option to end that version if they just feel if they're not going to get any value out of the versioning process and it might prevent them from putting data in. We kind of took the perspective that it's better to let them get their data in without the versioning on than to say, sorry, you have to go somewhere else. So that's the primary reason for that.
Uh-huh. But is the versioning causing any additional effort for the users if versioning is turned on?
We don't know that yet. This is more a prospective fear. So, but the way that we're doing versioning, especially if you have a large update to a data set, you need to match your column names exactly. You need to provide the exact same number of columns. So there's some constraint there on how you can upload data when it's being versioned. If you make a whole bunch of changes to your data and just say, I just want to get the data up there and available, then it's easier to just kind of delete and replace, and that's not tracked by the step-by-step versioning that we use. So that's the main pain point that we anticipate, and we give a lot of red lights and please don't do this, but we try and make it attractive to keep them in, but we want to provide that pathway at least as we start to roll this out, so that if there are users who are not going to want to use versioning, they're not going to get value from versioning, then we don't want to force them into that.
Yeah, no, that makes sense. That makes sense. No, that's very nice. Any further questions? Just checking the tiny set of little windows here. If there's anything that I missed? Data hashes, no. I don't see any new questions coming in. So in this case, Jemai, thank you very much for holding this webinar for us. Again, want to apologize for starting it with such a delay, but at least we figured out how to get it started in the end, and thanks to the help from people from the RDA, we could finally hold it. And the webinar is being recorded, so as soon as the recording is finished and has passed the post-processing by RDA, we will be uploading it to the website. So for all of those who couldn't join now due to the delay, it will be available. Okay, and if you're fine to share the slides, you could send them to me or upload them to the webpage as well. Then we will make the material available if that's fine with you.
Will do.
Okay. Thank you very, very much.
Yeah, thank you all for your great questions and feedback. I really appreciate it.
Very helpful. Thank you.
All right, take care, everybody.
Take care. Bye-bye.